This video shows you how to conduct hardness testing using the LECO. We'll start by showing you how to mount the sample if it's cylindrical. First, you're going to place it into the container, and then you're going to flip it upside down onto a towel so that you don't scratch the surface of the sample, and then you're going to tighten it to make sure that everything is level. Once it's securely in place, you can double check that it's level by bringing it to eye level. And then you can go ahead and slide it onto the plate so that it locks in place. You're going to go ahead and take out the flat plate by sliding back this button, and then you can go ahead and slide in the plate with the sample. This is what the button for removing the plate looks like up close. And then for this demo, we're actually going to use the flat plate because we're indenting a square sample, which you can just place on top of the plate beneath the microscope. And then we're going to begin lifting up the sample so that it's in focus under the microscope. We do this by twisting the outer knob to the right and then pressing the rightmost button to speed it up. And then if you get too close and need to zoom back out, you can twist the outer knob to the left and press the leftmost button if you need to speed it up. And then once you get close, you can just twist the center knob to bring it into focus. Twisting it clockwise brings it up, and twisting it counterclockwise brings it down. And then this is a sped up version of what it looks like while bringing the sample into focus. And then this is what the sample looks like once it's been brought into focus, but note that the surface of this sample is particularly dark. And then when you're ready to image the sample, you can click the top right corner and then select which one is the shape of the sample, and it will begin imaging it in that shape. So for this demo sample, it's square shaped, so we select the square and then it goes ahead and images in that shape. And then you can also image manually by just dragging the circle around the screen. And then this is what it looks like while it's imaging in that square shape. So that basically explains how to image the sample, and then here we've re-cleared the screen so that we can prepare an actual test. You're going to start by switching from analysis to sample at the top of the screen, and then you're going to select sample in the bottom left corner of the screen, and it will add this new sample row. And then you're going to go ahead and fill in the labels on the row, starting with the name of the sample, the project, the material type, and then you can put your name under operator, and it will automatically fill in the date and time after. And then this is what the sample row will look like once you've finished filling in all the labels. Then to begin preparing to test the sample, you're going to go ahead and select your sample row, and then go back to the analysis screen. And you can see at the top of the screen that you have the correct row selected. And then to begin preparing for testing, you're going to need to image the sample in the same manner that we showed before. Here we're using the square imaging tool because we have a square sample. Instead of using the tool, you can also just drag around the circle and image the sample manually. Now we're going to show some of the different tools you can use before setting up an actual test. So first, he selects the vector tool, which will cause it to pop up on your screen, and you can kind of move it around to place it wherever you want it on the sample.
The vector tool allows you to create an array of indents where you can specify the number of rows and columns, as well as the vertical and horizontal spacing between the indents. You have the option to either choose Vickers or Knoop test, but in most cases, such as this, we will be using the Vickers test. This test functions by pressing into the material at a defined load, and by using the indent tip geometry, can calculate the hardness based on the size of the indent on the material surface. As you can see, an array of vectors appeared on the screen after we clicked apply. There's a function that you can use to automatically space the indents far enough away that they will not affect each other. And you can do this by pressing the stagger button. In most cases, this isn't the best option, and it is better to calculate beforehand how far you want your spacing to be and make sure that it's within the limits of the machine. This will allow you to indent a more specified region. Some of the parameters needed for this test are the estimated hardness of your samples and the load which you are trying to achieve.
Here we change the load to 200, which means you need to go to the side of the machine and set that to 200 as well, because these always need to match before the test.
After you've changed your load, you'll want to go in and make sure that your estimated hardness value is correct. After you've made sure everything is correct, you can close out of the input section and your vector should be on the screen. There are many other tools you can use to place indents on your sample. For example, you can place a single indent and can adjust the parameters for the single indent just as you can for the vector array. You can see here that the user changed the indent from a Knoop to a Vickers and is moving around the indent to the location that they want the single indent to be placed. For many cases, a single indent can be used to know the orientation of your sample, especially in applications such as EBSD, where you cannot see the full sample when imaging. The line tool is similar to the vector tool, but will add indents on only one row instead of multiple. To remove an indent or placeholder for an indent, you can go to the column on the right, select that placeholder, and click Exclude, then Delete, as shown here. You can also move a single indent in an array. And if you accidentally do this and want to reset your array, you can go to the column on the right, select your vector, and add an array, which will override the one on the screen. Another tool you can use is the polygon tool, where you can draw your own path that you want the indents to take and place it on the sample.
You can also switch between the indenters and the lenses by selecting on this box on the left side of the screen. First, he selected Knoop, which is a kind of indenter, and then he switched to the 50 times objective lens. That way he can get better imaging. This is what it looked like when he switched from the 10 times objective lens to the Knoop indenter, and then from the Knoop indenter to the 50 times objective lens. Now with the 50 times objective lens, he can get a much more detailed image of the sample, and he's going to go around and re-image all the indents. Another tool you can use is the floating ruler, which is in the top right corner of the screen. You can place that near whatever you want to measure and then zoom in and out to be able to tell the distance between different things. You're going to be zooming in and out using the mouse, which looks like this. The crosshair is another tool, which is at the top next to the floating ruler. It adds a crosshair to the middle of the imaging icon to give you a better idea of where the center is.
Here we will now perform a test on the sample. We will use the vector tool to create a 3x2 array with 200 micron distance or horizontal spacing and 300 micron offset or vertical spacing. Once you can see and double check how your array looks, you can go from the analysis section at the top into the sample section and rename that vector. As an example, we have created two vectors to show you can rename multiple indents at the same time. As you can see, the vectors have now been renamed in the analysis section. This is useful when you have many vectors and want to keep track of which one is which. For this test, we are going to be using the original array we created. When you're ready to test, you'll click the Analyze button at the bottom and it will start the test. As you can see, the machine switched from the microscope objective to the Vickers objective and will now indent at each location on the sample. While the test is running, it will give you an estimated time of completion. When the test is completed, the machine will switch back to the microscope objective and measure the area of the indent. As you can see here, it is going to each indent location and measuring that indent's area. In this case, the load used was too small, and it did not make a big enough indent that could be seen by the microscope. So we will have to go back in and remeasure the indents manually. You can do this by clicking on the indent in the list at the bottom of the screen, and it will automatically take you to that location. You will then hold right-click on the line around the indent and click remeasure. You can then move the corners to the corners of the indent and it will remeasure. After you've done this for all indents highlighted red, the bottom list should be in plain text, and you can see a curve displaying the hardness of each indent themselves. You then want to output your data. To do this, make sure you are on the analysis screen and click on the output button in the top right. Select the format of who you want to output for and click generate. Excel will open with the output data. You can scroll through this to see that your data is correct. You can exit this out and open the File Explorer by clicking the Windows button on the keyboard. You will then go to the temp folder, and the first Excel file is your data. You will then rename the file and move it into the location you want. When you are done with the machine, select the 10x objective to give the most clearance to remove your sample. You can now carefully remove your sample.